This video is going to cover titration problems. So we have a balanced equation, and we know that NaOH is used to titrate a solution of HCl. This is an acid-base reaction. In this titration, there would be some indicator in the HCl to tell when the endpoint was, to tell when the reaction was finished. When that reaction was complete, then 76 milliliters of the 0.6 molar NaOH were required to completely react with the HCl. And there's 40 milliliters of HCl. So over here, I have the setup drawn. This is a burette, and it's dropping NaOH into this HCl down here. We started with 40 milliliters of HCl, and then 76 milliliters of this NaOH were required to react with it. And that NaOH was 0.6 molar. And so there's a couple ways to solve this. If you have a 1-to-1 ratio of acid to base, then you can use an equation that looks like this. Molarity of the acid times volume of the acid equals molarity of the base times volume of the base. So if there's a 1-to-1 ratio, which we have, you can use that equation. I'm going to do this a different way, though, that always works, even if you don't have a 1-to-1 ratio, molar ratio between the acid and the base in your balanced equation. So I'm going to find my moles NaOH, then convert to moles HCl, then find the molarity HCl. Just know you can do this shorter way if you want to. All right, so I'm going to find my moles NaOH first, my moles that reacted here. Well, to find my moles, I'm going to need to use this equation, and this is for NaOH. I'm going to need to use M equals moles over liter. While I know my molarity, I don't have liters, I have milliliters. So let's convert milliliters to liters. I'll do that up here. 76 milliliters. Drag down milliliters, go to liters. 1 liter has 1,000 milliliters. Cancel units that are on the top and the bottom. So I have 0.076 liters. Okay, so I have 0.6 molar for my NaOH. I can see that up here where I drew it out. So I'm going to plug in 0.6 for molarity equals moles divided by 0.076. To get moles by itself, I'm going to multiply both sides by 0.076. That cancels. 0.076. So now I have 0.6 times 0.076. And so my number of moles of NaOH are equal to 0.0456. Now I need to find my moles HCl. It's a 1-to-1 ratio, so it's going to be the same number of moles. I'll still set up the conversion just in case there was a time you didn't have a 1-to-1 ratio. So we have 0.0456 mole NaOH. Drag down mole NaOH. And I want mole HCl. I need the moles HCl because I have the volume and I'm trying to find the molarity. So that's why I need moles HCl. All right, I have mole to mole ratio. When I have a mole to mole ratio, I can look at the balanced equation. I see the coefficient is 1 and 1. So I put a 1 and a 1. Units on the top and bottom cancel. And I'm left with 0.0456 mole HCl. I'm trying to find the molarity of HCl, so I need M equals moles over liters. Let's see, I have moles. I need liters. I'm going to take 40 milliliters. Drag down milliliters, go to liters. 0.04 liters. So I'm going to take my moles HCl, 0.0456 mole, divide by my liters, 0.04 liters. And I get that the molarity is equal to 1.14 molar for my HCl. So as a refresher, I had my 76 milliliters of 0.6 molar NaOH that reacted with 40 milliliters of HCl. I found out that I had 0.0456 moles of NaOH. I converted that to moles of HCl. I found my liters of HCl. Moles over liters gave me 1.14 molar as the molarity of the acid.